Hello, today we're going to be doing problem 80, which is remove duplicates from sorted array 2, and this is part of LeetCode's top interview 150 questions asked. So given an integer array nums sorted in non-descending order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. It's impossible to change the length of an array in some languages, so you must instead use the result in the first part of the array nums. Most formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave behind the first k elements. Return k after placing the final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying the input array in place. Okay, so basically they just want us to put the output in the same nums array. So if you look at the first example, you can have at most two numbers that are the same. So we need to get rid of the third one in this case. So the answer is 1, 1, 2, 2, 3. So the answer is 5. K equals 5. And then the second example, we need to remove 2 1s. So basically all we're doing is removing these and then shifting these numbers downward. So k is 7 in this case. So how are we going to do this? Let's start with the first example. Alright, so this is the array. So basically we're going to have 2 pointers comparing the numbers, making sure we don't have 2 of each number. So what we're going to do is we're going to have a variable I, and that's going to go iterate through the array element by element. But because we can have 2 elements that are the same, at most 2, we can skip the first 2, and we need to do that anyway, otherwise it'd be difficult to compare a number to itself when it's just, if you don't have a starting at any point. Anyway, okay, so then we're going to have k. Well, k will be the number that we're going to compare it to. Well, if you compare it to itself, it's always going to be the same. So what we're going to do is we're going to back up 2 places. The 2 places that we moved, I, because you can have what was the exact, each unique element appear at most twice. So we can have it twice. Okay, so when we start the iteration, I is going to be equal to element 2, which is a 1. And then k will also be equal to 2, but we're going to subtract 2. So k will be equal to element 0, which is also a 1. So we ignore that. And we increment I. So I now is 2, and k is still 2, so k minus 2 is 1. Well, now those are different. So now we need to place the value of I in k. So this is why k is a placeholder that we don't move until we change it. So we can record that number. So now we have 2 there. And now we can increment k, and then it will also increment k minus 2. Oops, did that backwards. Okay. So now we're going to increment I again, which is 2. K minus 2 is 1. Okay, so now we have to take the value that's I and put it in k. And since it's already 2, it's just going to overwrite the 2, and that'll be that. So then we increment k. Nope, I did it again. Okay, so then we do I is 3. K is 2. K minus 2 is this element 2. Well, they're different. So that means you've got to take the value I and place it in k, which makes this a 3. And then we hit the end of the array, and so they're talking about the extraneous numbers after the end of the array. So your answer is, this is the final array, and then your answer is k equals 5. Okay, so the way we're going to code this is we're going to start with that k value and make it equal to 2. Then we're just going to iterate through the nums array. So int I, we'll start at 2. I is less than nums length I plus plus. Okay. So if nums at position I, remember we only care about it when they're not equal. So if nums I is not equal to nums, and now we're doing this is where the k minus 2 goes. K minus 2. Well, then we've got a situation where we have to move the numbers around. So we'll do the loop here, and then we'll make nums. If you remember from my example, it was the value k, and that equals, I'm going to assign that the value of the element at I. And that's pretty much it. Oh, more important, you got to increment k, otherwise that would be bad. And then at the end, we're just going to return k. Okay, let's run this. It looks like it's accepted. So real quick, I'm just going to debug it. Okay, just like my example I was using, we'd use the first one with k equals 2. So we'll step into this. So the value at nums I is, so I equals 2, so that is 0, 1, 2. So the value is 1, and then the value of k minus 2 is also 1. So it's just going to, not going to do anything in this case, just go back to the original loop. All right, now I is 3. So now we're going to compare the 2 to k minus 2. K is still 2, so it's going to compare to the 1. So now it's different. So if you watch and look at the array on the left, the third number becomes 2 instead of the 1 that it was previously. So do this again. Now remember, this is where it overwrites a 2 with a 2, so nothing's going to happen there. Okay, finally we've got I equals 5, 0, 1, 2, 3, 4, 5. So now we're at the last 0, 1, 2, 3. We're at the last number, we're 3, and then k is equal to 4. 4 minus 2 is 2, which is a 2. So then that's going to, so there you see, it turn that 2 into a 3. And now we're at the end of the loop, and return k, which is 5. All right, so there you have it. Let's submit it. And it is accepted, and it beats 100%. We are the fastest solution out there. And we did it all with the O of 1 space complexity. So there you have it. Thanks for watching, and we'll see you next time.